today is the results from your seed dispersal investigation. First thing I want to say is I was absolutely amazed at the quality of the results that you gathered and how many of you created fantastic results. So first of all, an absolute amazing pat on the back, well done, brilliant, brilliant, brilliant set of results. Now, if you look at that picture that's on the slide, what we are trying to find out is if the wingspan will have an effect on how long it takes the spinner to fall. Now, the longer it takes the spinner to fall, the better, because it will be caught by the wind and will be carried further away from the parent plant, so that seed will stand more of a chance of surviving and growing into an established adult plant. So we were going to try and investigate that to see whether the wing length had an effect on that, and we're going to have a look at our results now. So first of all, just a little slide just to show you some of the different examples of the helicopter style seeds, like the ones we were looking at in our investigation. I've already said how amazing your results were, and in a minute you're going to get to see them. So I've spent a few hours analysing these results, and this is an overview of where we're at. So don't worry too much about picking that to bits, but they're everyone's results. Now I've collated them all together, analysed them, and then tried to get some results. And the first thing I wanted to do was work out a class average for each length of wing. So these are our results. Because you're already in your 4 different classes, I used those as the classes. So we've got class 1, class 2, class 3, and class 4. Now, each class had an average for how long it took the spinner to fall for the different lengths of wings. So if we look at class 1, their average for the full wing was 2.3 seconds. Class 2, their average was 2.32 seconds. Class 3, 2.34, and class 4, 2.32. Now, bearing in mind you did this experiment independently in different rooms, you measured your 2 meters, you made your own spinners, possibly out of different paper, so there were loads and loads of variables. To get results as close together as that, I am astounded. They are absolutely fantastic. Now, what I needed to do then was work out an average. So one of the things that you need to be able to do from today's lesson is know how to work out an average for a set of data. So if we have a look at our next slide, we want to have a look at what the overall average is for a full wing. So we take all of our values. So here we've got 4 values, and we add them together. So if you look here, we've got 2.3, add 2.32, add 2.34, add 2.32. That equals 9.28. Now, to get a mean average for that, we then need to divide that number by the number of values. So we divide that by 4. And our overall average is 2.32. So whenever we're looking now at our results going forward, we're going to be looking at the averages for the entire set of data. So if we flip back, we'll look at this bottom line here. And hopefully you'll be able to identify a pattern. As we cut off more paper, we see the time it takes for the spinner to fall gets shorter and shorter and shorter. So it's spinning faster, to the point of where we've taken off 16 centimetres, so we've got tiny wings, it's spinning in just over 1 second. Now that supports what our original idea was, that long wings will make the spinner spin more slowly so it can get caught by air resistance and will get carried further away from the parent plant. Now, the table is okay, but it's a better way of presenting it will be to have a look at a results graph. And that's what I created next for us. So if we look here, we've got a really nice clear pattern showing. On the y-axis, we've got the time it takes to fall in seconds. And on the x-axis, we've got the length removed. So as we go along here, our wings get shorter, which will confuse people a little bit, but this is just the easiest way to show on the graph, as it was with your results table. So as we go along here, our wings are getting shorter and shorter. So this graph clearly shows the longest wings with hardly any paper removed take a long time to fall. And as we remove more and more of the wing and the wing gets shorter and shorter and shorter, the time it takes for the spinner to fall decreases, and it falls much, much quicker. So, what you're going to do on your first activity is analyse those results. So the first thing is to describe the pattern shown in the results. Now, whenever you do a question like this, we use the labels from the axes on the graph to help us. So what we can say is, as the length of the wing decreased, so as the length of the wing got smaller, the time taken for the spinner to fall, you could say, will get longer or get shorter. You've got to look at those results and decide what you think actually has happened. So as the wings got shorter, what happened to how long it took the spinner to fall? The second thing I've asked you to have a think about on the activity is explain the pattern that the results show. So why do you think that long wings will take longer to fall? And they're the two really important things that we need to be able to do from those results. Now, something else I've asked you to do is try and develop your idea of spotting anomalous results. Now, an anomalous result, you might have spotted these yourself when you were doing the experiment, is a result that doesn't fit with the pattern. So when you were dropping your spinner, you might have noticed once or twice that it didn't spin properly, or it hit something, or it got blown by the wind because the window was open. And then you looked at your timer and it was significantly different to any other results you'd gained. Now that is an anomalous result. In an experiment, we would identify that and we would discard it. We would do the experiment again. Now what we want to try and be able to do is identify anomalous results in sets of data. So if we look at this example here, we've got a set of data. Doesn't matter what it's for, it's just a series of numbers. But 0.63, 0.71, 0.64, 0.69, 1.2 and 0.67. Now, to identify an anomaly, you need to spot the odd one out, the one that doesn't fit with the rest of the results. And hopefully all of you can identify that the 1.20 result there is significantly higher than all of the others. So that's an anomalous result. We would discard that. We would not include that in our results table. And if we could, and we would do an experiment, we would repeat that experiment. So if we look here, we'll pick out class 1. We'll have a look at this data set here that I've highlighted. So this was for the 10 centimetre wingspan. So we scroll down and we look, we've got a result of 1.8, 1.5, 1.02, 1.24, 1.47, 1.52, 1.75, 1.45. These two you can't see, but they're 1.6 and 1.7. And then this result I've highlighted, 3.54. Now that is an anomalous result. It does not fit the pattern. So what we should do in that case is we should identify that when we're doing our experiment, discard it, and repeat the experiment for that length of wingspan or whatever else we're doing in the experiment. So you need to remember that an anomaly is a result that doesn't fit the pattern, and you should be able to identify them in a set of data. So going forward, these are the 4 questions that you're going to get on your activity, and then this sheet you can fill in as a Google Doc and just turn in. First question is explain how a mean average is calculated. Now I've talked about that in this video, so it might be you skip back and have a look at that. The second one is try and identify if there are any outliers or anomalous results in the data on the worksheet that I've given you. If so, which values are they, and how do you know that they are anomalies or outliers? And there might not be any, because they might all be quite close together and they might fit the pattern. It's up to you to decide. Question number 3 is I want you to complete the sentence which will describe our results. So as we remove more paper from the wings and they became shorter, you then say what happened to how long it took for them to fall. And then question 4, which you might need to do a little bit more research for, can you explain why this happened? Why did we get the results we did? Why was there that difference in the time it takes to fall based on the wingspan? And it might be do a little bit of research for that. You might need to have a look at how wing length affects aerodynamics. You might need to think about parachutes falling and air resistance. So quickly going through question number 1 again, looking at how you calculate a mean. So this should help you with the worksheet. So you might want to go back to the video and have a look at where I'm talking about that. Question number 2, remember an anomaly or an outlier is a result that doesn't fit the pattern. Question number 3, finishing off the sentence, describing our results. And then question number 4, trying to explain our results and explain what's happened. So that's what you need to do. Now the second part of today's lesson is about germination. I haven't done you a video for that, but I've linked in some BBC videos which should be really helpful. On Thursday's lesson, we'll have another opportunity for you to drop in, have a live chat, because that was really successful this week. It was really good to see some people and talk about how they were making their spin, and so I look forward to seeing more of you on Thursday's drop-in. Okay, I hope you got on okay with this, and I will see you next time. Thank you.